So my name is Gabi. I'm doing front-end for the last 5 years and currently leading the front-end team for Wix Answers, which is a product inside Wix. And I've done a lot of TDD and testing in the front-end world and gathered some insights. And today I'm going to talk about a design pattern that some teams at Wix started using. And in the same chance, I'm going to talk a little bit about TDD, front-end testing, and give my 2 cents about it, but it will mainly focus on the design pattern. So let's start with some assumptions. Because it's a fairly advanced talk, I'm going to make sure we're all on the same page, and if not, help you guys a little bit if something's not understood. So before that, how many are using React on their day-to-day work? Like, how many of you are shy and will not raise your hand, so I know how to ignore? Okay. So Angular, how many? Okay, that's better. How many have heard of the term components architecture, like building your app with components? Okay, amazing. A lot of people. Cool. So I'm going to assume you guys at least know what the component architecture means, what it means building your app with thinking of your app has a composition of a lot of components. Okay. Testing pyramid. Who knows? Someone doesn't know the testing pyramid? Okay. So testing pyramid means how much you spend doing unit tests, integration tests, end-to-end tests. I'm going to elaborate a little bit on those two. How many of you agree with the test pyramid? How many disagree? Awesome. I like. So I'm going to assume. Let's put aside opinions. Let's assume that we all agree on the test pyramid, and then we can debate afterwards. I'll be happy to do it. Okay, so I also want to talk a little bit about terminology. Unit testing, integration tests, end-to-end tests. Let's put those aside for this talk and think about tests as one single thing, just not to cause confusion. Because otherwise we'll have to make sure we all have the same definitions, and it will take a whole talk just for that. So let's face it. We all know, probably most of us know, that testing in the front-end world is hard. It's challenging. Another one, I'm hoping it will be the last time I ask you guys to raise the hands. How many do tests, like write tests? Awesome. Used to. Who used to? Not anymore? Because you... Sorry?
Basically starting my own business.
Okay. So you wanted to fail. So you wanted to... No, I'm kidding. Okay. Okay. Why is it challenging? Let's think of some of the reasons. We have so many technologies in the front-end world, especially in the last 2-3 years. It's been a blast. Like, if someone came into the developing world, someone came from another part of programming, for example, server-side or embedded programming, and it came to front-end after doing some of it a few years ago, everything will be very, very strange. We have React and Angular and even Vue.js. We do Redux. We use Karma. We maybe use Mocha. We have a lot of different technologies, and it's very confusing. When you want to start testing your front-end app, you first need to find the right tutorial, the right boilerplate. Too many options, and hopefully now our world is starting to get a little bit clearer on that, and people are starting to agree on a single stack. That's on the technology part, and on another side, think of a normal test of a function, where in a normal test take a look at the right side of the slide. You have a function, and it has an input and an output. It's very clear to know what you're going to test. You're going to test, you're going to put in some inputs. get out some outputs, and see if they match. The UI front end is a lot different. You have screens, you have pixels. There's no UI. There's no API, I'm sorry. There's no, we talk in actions, we talk in product, we talk in screens and not in a programmatic way, which is also a part of why it's challenging. Those two things and a lot of other reasons lead to some bad practices, anti-patterns. Now, again, let's all assume we all agree on the normal pyramid and go back then afterwards. So it might cause, for example, that one might have too many unit tests because he doesn't know how to test the Angular app or the React app. So we'll test a lot of functions. And will cause a weird version of the pyramid. For example, this is a turned upside down one. Someone might have a lot of tests on one part and no integration tests, but it depends on the case. Another thing that happens a lot, mocking. We tend to use mocking where we can avoid it. For example, I have a very hypothetical test here that says, for those of you who are less familiar with tests, the syntax, I will not use specific syntax. I will use describe and it, which is very agnostic. And I will also use a little bit of arrow functions, ES6, a little bit of TypeScript, but you can treat it as pseudocode as much as you care. So we have a test that has an app, and we create the app, we expect it to work, but we mock all the internal parts. That's one of the bad symptoms of not having confidence to test the real parts. The other thing that I've seen happening a lot is that people test their internals instead of the actual business logic. For example, they test the how and not the what. Here I have another hypothetical example of a test that checks for a working reducer. Reducer is a concept taken from, specifically I'm talking about the Redux reducer. If you are not familiar with Redux, just imagine that reducer is an implementation detail of Redux. And from the other hand, we have a test that tests the features. So the above, in my opinion, is wrong. The one below is the correct one if you want to test the what and not the how. Okay, so 1 second. The previous slides were my attempt to think of why testing the front-end part of apps is challenging. And it's an introduction to talk about the actual concept that I want to convey in the talk, which is component drivers. So to do that, I'm going to start with an example. Now, for those of you who are not familiar with TDD and testing at all, I'm going to assume I have a to-do app. Okay? Now, I will not write the application, the to-do app. I will assume that the app is a function that receives an element in the DOM and renders it. And I will talk about how to test it in the TDD way, and then see the problems that we have and try to solve it with the pattern, with the design pattern that is called drivers. So another thing I want to mention is that you will see small code examples. Don't worry, I will dive into deeper versions. So if you don't see anything, don't panic. So this is the first test. It's important to say that I'm not going to talk about the lines. Actually, I'm going to read the main part. So what we want to do is create a to-do app. And what I do here is I will first read it, and then I'll go slide by slide so you can read the code. I want to render a to-do app into the DOM. The to-do app will consist of an input and a list. I want to type something into the input, press a button, and expect that the item is in the list. Simple to-do app, the first case of our to-do app, to-do list app. So first of all, I'm going to create an element using the DOM API. I'm going to append the element to the body, and then I'm going to call my function. The function render to-do list is the function that I will not show. Just assume that it takes an element and a list of items and will render it into the screen. And then it will return an app. Is it okay until now? Any questions? You guys able to follow? Yep. Yes? Okay, awesome. So first, I render it into the screen. That's not the test part. I'm just preparing the test. Then I'm going to simulate that I'm clicking, that I'm adding something to the input. So how do I do that? I use the query selector API. It's a kind of new HTML5, I think, API, similar to jQuery selectors, but in the standard ECMAScript, in the standard HTML API. I will take the input, change its value, and then I'm going to simulate a click event on the add button. Then, and here the test comes in, I will search for all the items that have the class to-do item, and I'm going to expect that all the items equal to a single item array that is the first item I've added. Let's go back a little bit. So the value of the input is new item, it's a string. And then I'm going to expect that that's the single item. That's our first test. And speaking of TDD, if once it passes, we can go on with the next feature. How does it look in terms of clean code? Any points you guys want to add? Yes?
You have naked booleans in one of your function calls, and I want to fetch about it.
Yes, I have, the thing is I have naked booleans on one of my function calls. Can you point me?
There, false, true. I don't know what that means.
Yes, okay, that's a good question. That's a specific implementation of the way to trigger an event. You're right, we're going to abstract that. So, okay, fair point. Any other thing?
Aside of the fact that you have a lot of setup or tier up inside your
test,
and not in the classic tier up function, if you're working with any kind of UI framework like React or Angular, this code will just not work because your document is not going to look the way that you expect. Okay, so the point was that first, my tier up code, the setup of my test and the cleanup was part of the test. And the second is that it will not work with Angular or React. So the second point, I will show you that it will in the end. And the first point, let's think of it as a single test. That's our first test. We're not optimizing yet. If you guys know the TDD way of thinking, you first make the first pass test. You first have a failing test, then you make it pass, and then you refactor. Okay? Now, so how does it look? Like we can improve, right? But overall, it looks good. Now, it's a bit weird to think about as a green smiley, but we're not duplicating any code. We're not making any unnecessary abstractions. It's one test. It's our first test, so we might have a little points here and then, but we can live with that. Okay. So the first one passes. Again, we're not writing the actual code, we're writing the test. So let's say we made it pass, like the function works. Now we're going to write the second test. Let's see if okay. We're going to write the second test. Now I'm going to read it to you. Again, the actual, I'm sorry for the guys back there. I'm going to read it to you. Again, the actual code is not important here. And you have the slides and the code afterwards available. So the second test I want to create, the second feature, is that my to-do app will work with pre-populated items. For example, I can pass it a list of items, and it will render the items on the app. So I have 3 items, Angular, React, and Ember. And I render the app with those items, and then I want to see that the visible items I have, like I did before, is equal to that list. So our full test suite looks like this. We have this test above, the first one, and the second one. Now, how's it going so far? Is it bad, good? Anyone wants to add something after the second test?
I'm wet.
Yes.
What about adding a new item to a full list? You just tested an empty list and initializing a new list.
Okay, so the question is, what about adding a new item to a full list? Totally valid point. It will be a feature that we'll test. I just randomly selected this one. It's a valid point. It might be even better to start with a populated list on the first one. I just wanted to keep the first test as simple as possible. That's why I didn't do that. So does it look good now? You guys, yes?
It's wet.
Okay, yes, it's wet. Why it's wet? Because we are not, it's not dry. Okay, fair point, it's not dry. Everyone familiar with the dry concept? Do not repeat yourself.
You know the acronym for wet, right?
What?
Wet. Why everything twice?
Yes. Okay. I will talk about it. Don't worry. So it's a good point. It's wet, the opposite of dry. Dry, do not repeat yourself. A famous clear code concept. So it's wet. Why everything twice? We have this part twice, and we have this part twice. And you haven't watched it before, right? It's your first time. No. Yes. Yes. So we have a yellow smiley. It's not a green one, but it's not a red one. And anyone familiar with the rule of three?
Yeah.
Yes.
When you have 3 examples to study from. Or
yes. So the rule of three is kind of like a counter to why everything twice. In my opinion. Exactly, thrice. So we can change the T to thrice, and that's okay. We had twice.
Nobody uses that word. What is it? Breaking in the
Shachar uses it, and you should too. So I will explain to you guys what's been said there for those who didn't hear. So what's your name, by the way?
Nick.
Nick. So Nick said that the code is wet, which stands for why everything twice. We have twice the code that adds an element, twice the code that checks. Okay? So we have a concept called the rule of three. Until we have 3 duplications of the same code, we cannot be sure that we'll make the right abstraction, so we might better not do it. So we have a yellow smiley. It's not that bad. It's not that good too. Let's see. Let's write our third test. Our third test adds. Yes?
Yeah, I
Sorry.
have a question about the
Yes.
both of the tests. They test the functionality of the to-do component, but they're not testing the visuality per se.
Okay.
You don't actually test anything like, yeah, I expect the list to be blue with red headers. I'm just throwing.
Okay, that's a nice point. So the point was that I'm testing the functionality and not the looks. That's exactly why Anna, after me, will show you how to test the looks with screenshot testing, okay? I didn't plan for that, so thank you. So we had our third test with a counter, and the code here is that we have 3 items on the list, we add another one, the counter was 3, and we want it to be 4 now. Imagine it works, but because it does. So we add another one. We want to delete items when they're clicked. And we have, this is our full suit now. 4 tests. What about now? How does it look? Like, who thinks it looks good? It looks what?
Small.
Small. You're right. Can you see that there's a blur here that looks like this blur here, and this looks. Okay, that will help you with. Okay, for those who can't see, the red rectangles are duplicated code. So we have the first chunk here, the second chunk here, the third chunk here. Oh, I'm sorry, I just spoiled. Well, how does it look now? Not good. Good. Okay, bad smiley. Why? I just said it together. It wasn't planned. Okay, it's not dry. We have no separation of concerns. I forgot why I wrote that, so if someone has an idea, go ahead. It lacks abstraction, okay? It's a lot of implementation and no abstraction. We don't talk in English. It's a lot of imperative code, how to do it, not what we want to do. Okay, but that's a lot of buzzwords. Why do we care about it? Let's talk about our real work, not about some academic the jargon. So first of all, when we change class names of the to-do app, the test will break. It's tightly coupled to technology. Okay, for example, if I wrote it with Angular or React, I probably had to use things like scope digest or enzyme or React test add-ons to simulate clicks. It's hard to understand the feature. If you read one test, it will not make sense. It will not be pure English. And that's kind of a rich man's problem. Components that if you reuse components inside your app, for example, if you have a to-do app and inside of it you have another app, you will rely on implementation details. For example, class names, IDs, and tag and selectors. Eventually, you will not be able. You will not want to rely on them, and you will start mocking things. For example, what does it mean with our app? If the render to-do app function used another function for the items, for example, render to-do app item, and it accessed the class names and the selectors of that function, if someone else writes that function, the test will break if they change the implementation. It's hard to grasp because I had to have, I need a slide for that, but hoping some of you followed up.
Have them change the test.
You need to change the test.
They have to change the test.
Okay, but you require their part, so it's a problem. So what's been said that they need to change the test, but sometimes you have another team in another continent. We have those cases at Wix that write a piece of your app. Now we're talking about a to-do app, but it can easily relate to any size you guys want. Okay, so the main point is that tests are still code and they deserve to be clean. So in pure TDD we should have refactored a while ago, so now let's start now. Okay, let's extract the repeating parts. Let's handle the wetness part first. So we have the first part, which is a function that will click on an element. It's a click on function that receives an element and will simulate the click event. Now it will take care of the bare booleans that Nick said that we have, because they will be hidden away with a function. Now we have another function, get visible items, which will receive the element of the app and return a list of strings, an array of strings representing the items on the app. Okay. Now let's see how our first test look. You guys able to read? Okay, fairly? Kacha kacha, okay. So we have a new item, let's call it buy milk, and we have our app, we render it, and then we search for the new input, the new item input, we change the value. Then we use the click on function and the get visible items function, and the test fits the screen finally. Okay, good. Okay, 1 second, I think I skipped. Okay, it's good, but we're still missing something. I'm sorry, there's a hidden slide here, but I will improvise. We have, take a look at this test. The test still, the add item input dot value still is there. We are still exposing our implementation. The query selector word is still there. We want to remove all implementation details from the test and leave it as English as possible. So how can we do better? We can create an API to deal with our app. For example, imagine that this is a class, okay? I didn't write the class part and the constructor part, but let's assume we have some functions. For example, get visible items will return a list of strings, get count will return a number, add item will receive a string and handle the addition of the item to the list, and delete item will receive a string and delete it. Receive a string that represents an item in the to-do list and will simply delete it. Okay, that's the larger slide with the whole class together. So we have a class, we call it to-do app driver. It receives the element that represents our app, eventually the DOM element that the app was rendered to, and wraps it with those functions. Okay, now let's check how our test looks now when we use the drivers. The first test reads pure English. Almost pure English. It should add items to an empty list. Now we have component.add item receives the item, the string we want to add, and then we have an expect that the visible items is equal to the item we want to have. We hidden all our implementation details inside a class, and the test is short, is clean, and it's very readable. That's a green smiley with a greening face. So what we basically did is we created a driver for a component. Like, think of a vehicle driver. The vehicle is a complicated machine. Like we sometimes think it's simple. You know, there's there's an experiment that usually people. They asked people how simple they think driving a bus is, something like that, driving a truck, maybe someone knows the experiment better. And most people thought that they can do a much better job at driving a bus or a truck than an actual experienced driver can. Now, how does it relate to our component? Like a truck or a bus, we need a few APIs from the vehicle. We need to go to somewhere, we need to brake, we need to change gears, but one needs to know the implementation details to actually handle with the heavy machinery that's called a vehicle. And we can think the same of a component. For example, for a test to deal with a component, it needs to know the implementation details. So what we did in the previous slides is basically created a driver for a component. Now let's take a look. If you guys noticed, the first slide, the intro slide, had let's see if I can do it quick enough. No, I can't do it quick enough. Sorry. Okay, so the first slide had a few images of drivers, like from 10 years ago, when one would buy a new computer and had to install a lot of drivers to his hardware. Let's take a look on the definition of a driver, like as we know it in the regular computer meaning of it. So in computing, a device driver, commonly referred as simply a driver, is a computer program that operates or controls a particular type of device that is attached to a computer. A driver provides a software interface to hardware devices, enabling operating systems and other computer programs to access hardware functions without needing to know precisely the details of the hardware used. So I've highlighted the specific parts about the hardware in yellow, and let's switch it to something more of our word. So let's say that this jargon takes on, and maybe device drivers go out of the word, and we only know drivers as component drivers. Maybe I'm too optimistic, but who knows? So in computing, a component driver, commonly common as simply a driver, is a computer program that operates or controls a particular type of component that is attached to a graphical interface. A driver provides a software interface to components, enabled automated tests, and to access component functions without needing to know the precise details of the technology used. For me, it makes a lot of sense. I hope it makes sense to you guys too. Yes?
But do you prepare a driver for every component or every component type?
Okay, the question is, do I prepare a driver for every component or every component type? I hope I will get to it. If not, remind me again, okay? So in other words, let's take a look of remember the previous example. We created an API for a component. We actually turned a graphical thing like a product that had a specification from a product manager and a UX guy, and gave it a programmatic API, which helped us define the inputs and the outputs, okay? The inputs are the clicks, the add, the delete. The outputs can be the visible items and the counter status. And now that they're clearly defined in code, we can reason about them like we usually do in our job. We can think of the component as code and not as a bunch of pixels anymore. Okay, let's think of, now I will still address your question about component types and component. The idea is, and I will show an example, to write a driver for every component you guys write, especially if you break your app into smaller components. The idea in my code, each component, large or big, has its own driver, and I will show some nesting examples, but some examples where drivers use other drivers in a nested way. But yes, every driver, not every component type, not every component actually. Like each component you have will have its driver. Okay, let's take a look on some pros, some advantages that we have from using this pattern. Tests are much more readable now. You can easily understand the feature just from reading the code. That's a big point. Writing new tests becomes a no-brainer. You just take the drivers, the driver functions. If you need a new function, you go add it, but you get the motivation needed to write more tests. Now, when I say more tests, I don't want to say unneeded tests. I want to say tests, I mean tests that you wouldn't write otherwise because you were afraid of, you didn't want to repeat code, you didn't want to rely on implementation, and so on. Okay. Now, the third point, which is my favorite, is a little bit hard to grasp if you didn't do something similar before or use components in your day-to-day job. But nested drivers, for example, if we have an app, and it consists, and usually our components are always a combination of other components, right? We have like a to-do app that is a list of to-do items, and it has a header and a footer. When we use nested drivers, and I'll show an example, and never rely on the implementation of details of a nested component, but use its driver, we get the confidence to test the actual app and not start mocking things that we otherwise wouldn't do, and then we lose some of the integrity of our tests. Fourth is also, the fourth point is also a big point for me. Tests won't break when the implementation changes, given that the feature is the same. For example, if I don't answer it, I'll ask you again. In our to-do app, the tests won't break. Of course, the drivers will. We will change the driver a little bit, but the tests, the actual syntax of the task, the flow of the task, should not change. In our to-do app example, for example, if we change the delete functionality from a button next to the item to a pop-up that when you click on it, it asks you the index of the item you want to delete and press enter. We don't care. We will change the implementation of the driver. The function will still be delete item that receives a string and expects that the item will be deleted. Okay, some of the, sorry, did I answer your question? Yes? Okay. Some of the bad sides. So anyone think of something? I personally don't see any. Okay, like I think that if you write a lot of tests and if you do end up using implementation selectors and you actually use interact with the DOM to have real tests on your components, like any other technique, it's a pure refactor. It's nothing magical about it. So I personally don't see any disadvantages of it. Excuse me? Performance might be, but eventually, if I have to choose between performance, which will probably, it won't really affect, it's not an effect, but if I have to choose between performance or test readability, I will just get a new machine up in the cloud and pick the test readability because it's a better trade-off. Yes.
It feels to me that if I see the bad code in the beginning, it's easier for me to make the API, the driver. But if I have to do the
from the beginning,
it's like I'm gonna have to think how to make the API.
Okay, it's
not gonna be that good.
It's a nice point. So what you've said, the thing is that if we have bad code to refactor it, it's easy to make a good API. So first of all, of course, in real TDD, you start with something and then you refactor it. So you will, you don't have to abstract things that are not repeated. So the things will. The refactor will emerge. It's just a design pattern that you can think of, like next time you write code and you have like big duplication of selectors, you can say, okay, I can use that technique. And when you're used to it, you start writing your tests like if you're assuming you'll have a driver. Personally, that's how I start a new feature. I assume I have a driver, and I talk the API like I make it work like first I create a driver, and only then I create the actual feature. So with some practice, it actually works. I want to talk a little bit about nesting. Let's see our first example. We have the to-do app driver. And now let's imagine that the to-do item, the actual item that renders on the screen, it got a lot complicated. The designer wanted some cool effects, and we had to use different kinds of elements, and we want to highlight specific words that, I don't know, think of some weird, crazy scenario where it should be its own component. It has a lot of logic. Now we will stop, if we nest this pattern, for example, in this line here, I have the laser. If I can create a driver for the to-do item, and now the get visible items function that used to rely on the new item elements that it found and return the text, will now assume that it will just create a new instance of the to-do item driver and then call an API. Like we're imagining that the get text is an API of the to-do item driver. So I will try to explain it again. We will not, once we refactor the to-do item itself into another component, and we have a driver for it, I'm assuming that we import the driver as well. For example, we have a folder inside our app called to-do item and then to-do item driver, and I use it. Now I can be free to continue testing my app, relying on the real implementation of the to-do item driver without fearing that the test will break because some programmer changed the class name from this to that. Actually, in this example, it will happen. No. I'm using the component, and this is my wrapper. The element inside will not change, and the implementation can change as much as he likes, as long as the driver stays the same. And if the feature won't change, the driver will stay the same. I take it to the extreme, and I compose my drivers out of smaller drivers and smaller drivers. And we get to a point where even a button or an input have their own driver. For example, what functions do you have on an input? You have set value, get value, clear, For those who've used the Protractor, it's kind of built in the API, but it's all syntax sugar for other things. Protractor. If for those who are not familiar, Anna will talk a little bit about it and will explain what it is. Okay. Now, for your point, I'm gonna show. I'm afraid it cannot. It's a big concept, and it can fit into 40 minutes talk, like the whole process of writing the app. But I will show an example of the to-do app, a working test suite, and then I'm going to change the implementation from vanilla to React. And by changing the driver, we'll see that the tests still pass, and we don't need to change the tests. Okay. So let's make it bigger. So a small tour. Okay, so I have, bigger. Okay, is it? This size is okay? Okay, awesome. So, I forgot to ask, who doesn't like TypeScript here? Yes, amazing. Let's talk afterwards. I have my app.ts. If you're not familiar with TypeScript, hey, TypeScript, think of it as pseudocode. Okay, it's pseudocode that works. We have, it works and it scales, and it prevents me from a lot of bugs. And so our app, I didn't invest much time thinking about it, but that's the function we've seen in our slide. So it takes an element and some items, and it has some template, some string templates. It works. Okay. It's not the best code because I had to make the tests look good, not the actual app. So I'm sorry if you guys see weird things there. Okay, now we have the actual test that we've seen. Let's run them to see that they all work. Now that, okay. I did npm run test. I'm using Mocha. I'm compiling the TypeScript files into JavaScript, and we have 4 tests passing. It should add new items to the list. All the 4 tests we talked about. Okay. Now we heard that React is the new kid, the new cool kid on the block. So we want to refactor our app into React. So we have this one now. It's a to-do app that has normal React, simple React app. No fancy things, no Redux, no, yes, smaller? Just a bit, sorry. Okay, again, the thing is to show you that it's not, it's a React app. Now, in my tests, what I do is I import the render to-do list from a file called app. And the file called app uses, app vanilla. I'll switch it to app React. Okay? Now the tests should not work because the driver implementation should change. So let's see. So we have some errors, like it expected nothing to be a list, and it can't read text content out of null. Those things happen because I changed the actual selectors. For example, let's show you in the React app, I have the class name is to-do. Sorry if it's a little bit unclear. And in the vanilla one, the class is something else, new item. And that's just a small example. The click list, the triggering the click event is not the same, and some other differences. Now, this is my test. I import the driver from a file called vanilla driver. The vanilla driver is similar to what I've shown you guys. Now I'm gonna switch the implementation of the to-do app driver. The functions are the same. The API is the same. We just change the implementation and we run the tests and they work. And we found out that React is a little bit slower than vanilla. So we cancel the whole refactor project and go back to vanilla. Just to show you that I'm not, like I usually do that when I, let's not add the item here and see that the tests fail. Okay, so I commented out one part of the test and the test failed. I didn't show you anything magical. So yes.
Show the React driver?
Yes, sure. It's very similar, and we have the code online. So maybe I'll just yes, I'll share the code. It's on my GitHub page. Now it's not something reasonable. The thing here is not go write some drivers so you can switch from technology X to technology Y. It's that thinking about what you want to do and not how you want to do it, and hiding the implementation details and abstracting them will only make you win in the long term. And even with large refactors, for example, switching technologies, Redux, Mobix, React, and the other, anything that doesn't change the actual feature will stay the same. Okay, some final words. With this technique, you can build your tests around features and not around implementation. And you can still do isolated unit tests when you need them, but you can test your component, and your app is eventually a big component if you do components architecture. So why not test it as a whole? You can focus on the what and not on the how. Like I said before, you can even move from Redux to Mobix, which, for those who are not familiar, are both technologies to deal with state management. Terminology here, it's kind of vague. You know, is it a unit test, an integration test, an end-to-end test? The end-to-end test part is easier to agree on that it's kind of not, but maybe it is. Well, it's not. But is it a unit test or integration test? Who cares? As long as we test our actual feature and we don't have bugs on production, that's what should lead us. We can even use third-party components safely. We can write a driver for them and then rely on their implementation and do not have tests passing when the package you installed stopped working. And maybe one day, who knows, it will become a thing and you will npm install a component and you will be able to require its driver. One thing that we do in our team, we started an Angular app, and then we decided that we want to test React. So we wrote a small chunk in React, and we wanted to test the actual functionality of the React part inside the Angular one, but we didn't want to rely on implementation, so we exported the driver of the React part, and we used that on our tests, and if the feature didn't change, the tests still passed, even if I changed the implementation, which is something wonderful that we just gained from that. Questions? Thank you.